So hello everyone. Today we are going to start with a new topic, that is transport layer. So in this we can see there is one host A, okay, and inside a host A there is some process P1, P2 is running, okay, and there is one more host B, and inside host B there is some process P3 and P4 is running, right? Now there are some routers in between. There are some routers connected, which is R1, R2, R3, R4. Okay, so this may be in one, this entire host may be in one network, this may be in some another network. Okay, so assume like this. Now consider when you're sending a packet from one host, for example this is a host A to host B, from one host to another host. Okay, this is called host to host delivery. This part is called host to host delivery. Okay, and host to host delivery is a responsibility of network layer. This is a responsibility of network layer. Okay, now when you're sending a packet for one host, for example this is your host A, right, and you're sending a packet from this host to another host B. For that purpose, host that packet, that particular packet will start its propagation from here, and then it will travel to router R1, then R2, then it will propagate to R3, then R4, then finally from R5 to host B. This is how it's going to propagate. Okay, now after when you start your journey, when the packet will start its journey, then from host A to router R1, from host A to router R1, this is called one hop. This entire thing is called one hop. Okay, R1 to R2, this entire thing is called hop 2. Okay, this is hop 3, then hop 4. So this is entirely one hop. Okay, one hop, one hop, one hop. So like this, after 5 hop you reach to the host B, right? Now this is called hop to hop delivery. So when you are traveling, when your packet is traveling, when it reaches this R1, okay, from R1 to R2, this is called one hop. So this hop to hop delivery, that is responsibility of a data link layer. Okay, so when your packet reaches here, okay, starts this journey from host A, and from host A, when it reaches to R1, this is called one hop, and this hop to hop delivery is a responsibility of data link layer. Then after that it will go to R2, this is also one hop. So this host to host delivery is a responsibility of data link layer. So all this hop to hop delivery, it's a responsibility of data link layer, and it is also known as node to node delivery. There is one more name is node to node delivery. So what if, because we are consider this particular router as one node, okay, or any machine, okay, we are considered as a node, so it is also considered a node to node delivery. So remember, it's a responsibility of a data link layer. Host to host delivery is a responsibility of a network layer. Okay, see, we have to understand one thing, that the real communication happens between process to process delivery, not between computer to computer. Okay, see, computer can't communicate with each other, they are just a machine. Okay, it's all about, it's because of that process which is executing inside the host, which generates some data. Okay, and that data has to be communicated from one process to another process. For that purpose we are doing all these things, right? So that data, for example P2 has generated some data, okay, and that data has to be traveled from P2 to, suppose we have to travel from P3, that data has to be sent from P2 to P3, right? So we can't directly send that particular data to P2 to P3. So for that what we are doing is, this particular process P2 is inside a host, right? So that data will be there, and now this data will go to this node R1, okay, that is a router. Then from there it will go to R2, then from that it will go to R3, then R4, then finally it will reach to host B, and from host B it will reach to process P3. Okay, so this is called process to process delivery. Okay, or we can also, there is one more name is end to end delivery. Okay, and this is the responsibility of transport layer. So end to end delivery is a responsibility of a transport layer. Are you getting it? Now we had seen that back then we are delivering a packet from host to host, right? This host to host delivery, that is the responsibility of network layer. See, for delivering a packet from one host to another host, we have to uniquely identify a host. We have to uniquely identify a host within this entire world, okay, within the network, within the entire world. So how it is possible? That is possible with respect to IP address. So where every host has an IP address, which is a unique identification number, right? So using that, we can uniquely identify a host within the entire world, right? Now for node to node delivery or hop to delivery, you have to uniquely identify the node. For example, R1 is one node and R2 is one node, right? This router. Okay, so if you want to uniquely identify a router R1 and R2, for that we have something called MAC address. Okay, because at data link layer, if you want to uniquely identify any particular device, we need a MAC address. Okay, we will not make use of IP addresses. Here we make use of MAC address. Okay, so every router R1, R2 for hop to hop delivery, we will make use of MAC address. Okay, now for process to process delivery, okay, it is a responsibility of transport layer, as we see. For that, we need a unique identifier, okay, and that is a port number. So that a port number will uniquely identify a process within a host. See, a host is a computer, okay, and a computer can we know that in operating system also we might have learned it, that a host can have a multi-programming running inside a computer. We can have a multi-programs running inside of a computer, right? So if there are, for example, in this case, host A has P1 and P2 running inside a computer, and here host B also having P3 and P4 running inside a computer, right? Because it supports a multi-programming. Now if P2 wants to send a packet, right, to a P3, then when that packet delivers at host B, how it will uniquely identify that that particular data is for P3 or P4? How can it will understand? Okay, for that, okay, otherwise, see, if P2 is sending a data, okay, and this data has to be exactly reached to a P3, okay, it should not reach to P4, because both are, see, data will reach to host. When you are sending a data, then data will reach to the host B, and in the host B there are two processes running. Okay, then the computer will get confused. Then that data has to be delivered to P3 or P4. How computer will rectify this problem? Using a port number. Okay, so every process will have a unique identification number, that is called a port number. So using a port number, it will understand that particular data has to be delivered to that particular process. Okay, so otherwise it will deliver to some wrong process, and that will be a chaos. Okay, that should not happen. So for that purpose, we need a something called port number. Okay, so we understood that for host to host delivery we need a IP addresses. Okay, and it is a responsibility of network layer. And for node to node delivery, that is called a hop to hop delivery. Okay, for that we need it's a responsibility of data link layer. Okay, and for uniquely identifying a device within a one hop, we need a MAC address. Okay, and for uniquely identifying a process, we need a port number, because transport layer has a responsibility of delivering a packet from one process to another process. For that we need a port number. Okay, for uniquely identifying a process. So whatever I said before, I had written here. See, data link layer is responsible for hop to hop delivery, right? Which is also called node to node delivery. Network layer is responsible for hop to hop delivery. Transport layer is responsible process to process delivery, which is called end to end delivery. Okay, and we can see the same diagram. This diagram I taken from Forozan book. Okay, so this is a host A, host B, right? And this is a routers, okay, which is called node to node delivery, from one router to another router, or from one computer to another router. or from router to another computer. This is all are called hop. Okay, this is one hop, second hop, third hop. Okay, this is one hop, right? One hop. So all these are hop. So hop to hop delivery is a responsibility of data link layer. So all this thing we had seen. Okay, so everything is there. This I had taken from a Forzen book. Now we understood that the real communication is between a process to process, right? So if you want to deliver a packet from one process to another process, generally we need a port number. So that we understood that we need a port number, right? Right. So assume that I want to deliver a packet from process P2 to process P3. Okay, in this case. So this process become a source, P2 become a source, and this may be considered as a destination. Process P3 is my destination. Now, my question is, what would be the source port? Say, if you want to deliver a packet, then you need a source port number, right? So what would be the source port number? What would be the source port number? And what would be the destination port number? What would be the source port number and what would be the destination port number? Now talking about the source port number, okay, remember one thing, that whenever the operating system starts whenever for example, whenever this P2 process starts, whenever this process P2 starts inside this host, then operating system will assign a randomly generated port number to the P2. Okay, remember this thing. Again, I'm telling, whenever this process P2 will start, okay, your operating system will randomly generate some source port address and assign to P2. Okay, now consider that assigned port address would be, source port address would be 52,000 something. Okay, so your source port address means source port number will be 52,000, and this is randomly generated by operating system. Are you getting it? Now we understood that we had taken a source port number which is 52,000, okay, which is randomly generated by an operating system, right? Now my question is, what would be the destination port number? Suppose even destination port number is randomly generated by an operating system, okay, at the receiver. Okay, see, sometime I'm calling this P2, sometime while teaching I may call this P2 as sender, source, client. Okay, don't get confused. Or sometime I call this P3 as receiver, destination, server. Okay, all these are terminology. I may interchange this terminology, so understand according to the context. Okay, now suppose destination port address, okay, it is randomly generated by the operating system, then there is a problem, right? In this case, I think there is a problem. See what will happen. See, when P2 wants to send a packet, what will happen? See, when P2 want to send a packet, I told you previously also that this data, okay, this data is inside a header, inside one header. Okay, it's like an envelope, and this header contains all the routing information. Header contains all the information so that you can reach to the particular destination. What is that? One of the information we needed right now is source port number and destination port number. Okay, source port number we know, that is 52,000, which is randomly generated by the operating system. But what about the destination port number? That is the problem, destination port number. Now the thing is, if I am telling you that at destination also operating system is randomly generating the port number, then how sender side, at a sender side, when it is generating a packet, okay, it has to at the header itself, okay, it has to put that destination port number, okay, and which is not possible to know, right? Because see, when this packet is generated at the source, when this packet is generated at the source or at the sender side or at the client side, okay, prior to sending all this packet to the destination, prior to that, all this information about the source and destination has to be known. Otherwise, you can't send the packet to the sender, to the receiver. Okay, so how can you know the destination port number? Because it is randomly generated by the receiver, right? So what they done is, one solution is what they suggested is, for resolve this problem, what they suggested is you can send one inquiry packet, okay, from the sender to receiver, okay, and this packet will go to this particular process, okay, and this process will reply port number, right? Now the problem in this solution is that there is an overhead at the network, okay, because it will increase the traffic in the internet, and we will not allow such solutions, because if the traffic is there, then there would be a lot of congestion. Okay, so because a lot of packets, lot of processes within a computer, there are a lot of processes running, and for every process, to just for knowing the port number, if you keep on sending an inquiry packet, then you just imagine how heavy the traffic would be, okay, in the network. So this solution was discarded. So the next solution is that assign a well-known port number at the server side. So now what I'm doing is that I'm calling this particular P2 as a client process, and particular P3 I'm calling it as a server process, okay, and I had given one name also, okay. The name of this P2 I'm giving is datetime client process, and the name of this P3 is datetime server process, okay. So remember this is called datetime client process, this is datetime server process, okay. This is just a name, okay. Now what I'm telling is, the solution is, you just give a well-known port number. For P3 I will give a well-known port number, well-known port number, means that is called a universal port number, universal port number. Instead of randomly generating the port number by the operating system, we will give a universal port number, okay. See, what is the benefit of it is that see, the universal port number means it's a well-defined port number which is known by every other processes, okay. So it will be known by every other processor. So that's why, for example, just consider the situation, let daytime client process, when it starts sending up packets, then that particular packet will be received by the daytime server only, okay. So we know that thing, when the daytime client process is sending a packet, then that particular packet will be received by the daytime server only. And for that purpose, if I instead of randomly assigning the port number, if I give a well-known port number for this particular server process, which is a daytime process, then I know, see, this particular process, the port number is randomly generated, that is okay. But when it's sending this daytime client process activated, then P2 as a process, it knows that I am going to send it to the daytime server, and for that I already know the port number, which is globally known, which is well known, which is universally known, okay. So that is already assigned. What would be? So for example, I am already declaring it that my daytime client process, its port number is 30, which is well known to every other processes, okay. So when yours, now in this case, here the source port number is 52,000, right? Now destination port number, that is well known, so we already know that we are going to send to the daytime process, so it is 30. So now that problem Okay, so there is no problem. We already know what is the source port number, what is the destination port number. So because of this technique, the P2 will send a process, will send the packet from this process to the server process, which is P3. Okay, by using this particular technique. Okay, so what we have learned is that at sender we will randomly generate a port number. Okay, but at receiver, okay, that is we are calling it a server process, it will not randomly generate a port number by the operating system. It will be generated, it is a well-known port number which is already assigned to that particular process. Okay, so by that solution, by this solution we can send a packet from one process to another process. Now there are few terminology. This whatever this randomly generated port number, we are calling it as, there is one name also for it. So we are calling it as ephemeral. We are calling it as ephemeral port number. Okay, which is also known as temporary port number. Okay, so this randomly generated port number, which is also called as ephemeral port number. Okay, so this is just a terminology. I just want you to know, that's it.